Hello, this is Mario from Odeon. In this video, we will talk about setting absorption and scattering in your model. Assigning acoustic properties to the surfaces in your model is an essential step before simulating the acoustics, and these properties should accurately represent the real or planned room's materials. These settings are found in the material list, to which we can go by clicking on this icon. At the left side of the screen, you have the layer list or the surface list. By default, it will be in layer mode, meaning it will show a list of layers rather than a list of surfaces. If you have defined layers or tags in the original 3D model, they will show up in the Layers column. These layers are not defined inside Odeon. Rather, they must be defined in the CAD software where the geometry was drawn. If your model doesn't have any layers defined, it may only show one entry. You can expand the layer list into a surface list by clicking on this icon. You can check whether the list is in layer mode or surface mode by looking here. And you can toggle between the two modes with the same button. Having layer data in your model dramatically simplifies the workflow in Odeon, so always try to import your model with layer data. The 3D render at the top will show the layer colors. To switch between the outer and inner view, first click on the top window to make it the active window. Then toggle with the Tab key. You can also save inner and outer views and cycle through them. Saving views, as well as changing layer colors, is explained in our tutorial on the 3D view and 3D render. The views saved in the standalone 3D render are also accessible in the 3D render in the material list. You can toggle between this 3D render and a wireframe view with this icon. You can also select your preferred default by going to the Options menu, Program Setup, Other Settings, and toggling this checkbox. You can toggle layers by clicking on the Set Layers icon. This button is only available while in surface mode. Let's disable everything except the reflectors. You can now see that surfaces other than the reflectors have been hidden, not only in the 3D render, but also in the surface list. I will go back to the normal view by toggling off Set Layers. At the right side of the screen, we have the Material Library. This is a list of materials you can assign to surfaces in your model. Pre-installed materials and those created manually within Odeon will only contain absorption coefficients in octave bands, from 63 Hz to 8 kHz. Notice that they are also displayed with a bar graph. Imported materials can contain absorption coefficients in 1/3 octave bands, as well as scattering coefficients. But we will talk about that a bit later. By default, materials will be grouped in ranges of numbers like this. This doesn't mean we actually have, say, 1000 brick materials. These are just ranges that are reserved for different categories of materials by default. You can search for materials by typing in this box, and you can search either by description or material number. If you close the search bar, you can re-enable it here. You will notice that this column also has colors. These colors are not arbitrary or manually defined. Rather, they are automatically generated based on the shape of the absorption curve. So, it helps to give a rough idea of the absorption properties of the material. These colors represent reflectivity in a way analogous to the light spectrum. With absorption of high frequencies, you have reflection of low frequencies associated to red. With absorption of low frequencies, you have reflection of high frequencies associated to blue. So, materials especially absorbent at high frequencies will be more red-colored, while materials especially absorbent at low frequencies will be more blue-colored. Also, with more overall absorption, you get darker colors, again, just like with light. Layers and surfaces will also show the colors of the material assigned to them. You can toggle between layer colors and material colors in the 3D render by clicking this icon. This makes it easy to distinguish absorption of surfaces at a glance. In this example, the audience area is a dark red, meaning it mainly absorbs high frequencies and has plenty of absorption. On the other hand, the ceiling is a light blue, meaning it mainly absorbs at low frequencies but has little overall absorption. Material colors will be the default in the standalone 3D render. The material colors can be changed for partial color blindness. To do this, go to the options at the top, Program Setup, User Interface Colors. Here, you can select alternative color schemes for the materials. For example, let's select the green-blue color scheme. In this case, absorption of low frequencies will be associated to blue, and absorption of high frequencies will be associated to green. The grayscale will only represent the amount of overall absorption. Keep in mind that here, you can also change the colors of other elements in the interface. You can find more information about the selected material by clicking this icon. You will be able to see the absorption coefficients in full octave bands, as well as absorption and scattering coefficients in 1/3 octave bands if available. If you use materials with coefficients only available in full octave bands, Odin will internally interpolate for 1/3 octave bands. Some additional information will be available for imported materials. If the manufacturer has provided the data, you will also see the company logo, picture of the material, and buttons for documents such as the brochure of the product. Additional material properties will be displayed in this table. And a material can also include diffusion coefficients. However, diffusion coefficients are not used in calculations, and they are only shown for informative purposes. You can scroll through different materials with the information window open. There are several ways to assign materials. A basic way is to select both the desired layer and desired material, and then click on Assign Material. This will assign the material to all surfaces in the selected layer. You will see both the material color in the first column and the material number in the second column. You can also assign materials to individual surfaces in the Surface mode. This moves the cursor to the next surface, so you can just click repeatedly. You can do the same thing with the Insert key. You can select multiple layers or surfaces using Ctrl-click or Shift-click, and assign a material to them simultaneously. Remember that you can sort the surfaces by clicking on the headers. So for example, you can sort by layers. In certain occasions, you may need to find the surface number of a specific surface. To do this, shift-click on a surface. If you're in the outer view, Odin will show you all the surfaces that the click goes through. Then, you can select them to identify them. If you're in the inner view, Odin will directly highlight the surface in the surface list. This global replacement will assign the selected material to all surfaces with the same material as the selected surface. Global Assign to Layer will assign the selected material to all surfaces in the layer of the selected surface. This button will assign the material to all visible surfaces. If you have disabled layers through Set Layers, the material is only assigned to the currently visible surfaces. If there is more than one material in a single layer, and then you switch back to the layer mode, that layer will be marked with a red color in the material column. You will also get a pop-up warning. However, there is no problem with having more than one material in a single layer if that's what you need. This is only a warning that if you assign a new material to the layer, then it will be applied to the whole layer. Down here, you can see the absorption coefficients of the currently highlighted surface or layer. You can also manually edit the coefficients. Keep in mind that this will change the coefficients for all surfaces with the same material. But it will not update the material in the material library. You can check for differences between the materials in your surfaces and the materials in the library with this button. Here, I will reapply the material to the whole layer, so that the material in the library and the material in the surfaces are again in agreement. You can add a new material to the material library by using this icon. By default, it will create a copy of the material currently selected in the material library. Then, you can rename it and enter new absorption coefficients. You save the material by closing the window. The material calculator is explained in a different video. You can also import multiple materials at once by copying them from a spreadsheet. Each material must include a set of absorption coefficients in octave bands. And from Odion 19 and onwards, you can also import absorption coefficients in third octave bands, scattering coefficients, an image of the material, and more. The category property is searchable in Odion 19 and later. So for example, you can categorize materials by type of surface, such as wall, floor, or ceiling, and search for it in the material list. To create a material sheet with your own materials, you can download the Excel template on our website odion.dk, Downloads, Spreadsheets, Material Template. You can also find instructions on how to use the template. We also have material lists from various manufacturers which you can download from our website under Downloads, Materials. When your spreadsheet is ready, simply copy the full table including the headers. In the Add New Material window, go to the Paste Materials from Spreadsheet tab. Here, paste your spreadsheet. You can double-check whether all the information looks right. Then, enter the starting material number where your materials will be inserted. We recommend to follow our default number range guideline. Finally, click on Add Materials and close, and Odin will import the materials. Here, we have created these new materials in the Global Material Library, which is the default library for every room you work on. But maybe you want to have an individual library exclusively for the room you're currently working on. For that, you can toggle between the Global Material Library and a material library exclusive to the room with this icon. If a local room library has not been created for the current room, clicking the button will create it. Then, you can modify this local library, while the default library for other rooms is kept intact. You can tell whether you are in the global library or the local room library by looking here. The local library is also handy when moving your room files to another computer. To edit a material already in your library, you can either select it and click on this icon, or you can simply double-click on the material. Keep in mind that materials imported from a spreadsheet cannot be edited within Odin. Once you have finished assigning your materials, you can get a rough estimation of reverberation time using statistical formulas like Sabine. To do that, click on this Quick Estimate icon. These are not meant to be the final results provided by Odin, which you will obtain later in the job list. But the Quick Estimate gives you a rough idea of the reverberation time with your current materials. This allows you to experiment by changing materials repeatedly before running a lengthier simulation. There is other useful data in the Quick Estimate. You can look at the absorption area of your different materials in the Material Overview. Here, you can even look at the air absorption, which is important in larger rooms. The Unused Absorption tab shows you the assigned materials with the most potential to add more absorption. The Alpha tab simply shows the absorption coefficients of all your assigned materials. The material setup is automatically saved every time you close the material list. And each time the material list is saved, a version of your material setup is saved in the Material List archive. This allows you to restore previous versions of your material setup. The description of your current material list is displayed in the title bar, while the different entries listed here are other material lists you can restore. Typically, these are older material lists, though some can be newer ones if the current material list is an older one you restored. The descriptions of the material lists are taken from here, so we recommend to update the description before each time you save the material list, so that later you can distinguish the different versions of your material list. You can manually save the materials and description without closing the window by clicking this icon. To restore a previous version of your material list, select it and click OK, Restore Materials. If you click on Restore Materials and discard current materials, the current material list will be deleted upon restoring the selected one. Additional to the absorption coefficients, the scattering coefficient is also important to keep in mind. In ODION, you only specify the scattering due to surface roughness. Scattering due to edge diffraction is automatically calculated by ODION, which we will explain a bit later. The standard way to define scattering in ODION is the single-value scattering coefficient. This is the scattering at middle frequencies, specifically 707 Hz. Then, ODION derives the values at the other frequencies based on these curves, which you will find in Chapter 9.5 of the user manual. You can access the manual by going to Help, User's Manual. There are cases where the 3D geometry has to be simplified, and the effect of small details must be compensated with a higher scattering coefficient. Two typical examples of this are audience areas and bookshelves. These produce complicated acoustic effects that cannot be directly modeled by ray tracing, image source method, etc. The way to get accurate results in these cases is to model them as flat surfaces and assign an appropriate single-value scattering coefficient. In Chapter 4.7 of our user manual, we have scattering coefficient suggestions for some typical cases. These serve as a starting point, but you can always experiment by slightly varying these values. For example, here we have the audience area modeled with flat surfaces. We have an audience area material that we have assigned for the appropriate absorption coefficients. Then, we will enter a scattering coefficient of 0.65. In the layer mode, you can enter a scattering coefficient for all surfaces in a layer. You can also add a scattering coefficient to individual or multiple surfaces in the surface mode. To do it for multiple surfaces, first add it to a single surface. This value will be automatically saved in memory. Then, select multiple surfaces using Ctrl-click or Shift-click and click on Repeat Scattering Coefficient for selected surfaces. This will paste the last coefficient you entered manually. By default, a scattering coefficient of 0.01 is assigned to all surfaces. A scattering coefficient of 0 is impossible, so there should always be at least a little bit of scattering. While 0.01 may be okay for smooth walls, you might want to adjust it within our recommended ranges. A yellow color in the scattering field indicates that this is still the default value and hasn't been manually changed, so it encourages you to take a second look at it. An alternate way to define scattering is to manually define the curve yourself. To do this, first tick the Scatter checkbox. Then, enter the values for each octave band. The red curve overlapping the bar graph is the scattering curve. Surfaces with manually defined scattering curves will be indicated in the surface list with a gray cell. Also, when defining scattering in this way, the curve will apply to all surfaces with the same material. To go back to using the single-value scattering coefficient, simply untick the Scatter checkbox. As previously mentioned, scattering due to edge diffraction is automatically calculated by ODION. In this example, we will see a different amount of scattering from a flat wall versus a group of smaller walls, even though they all have the same scattering coefficient entered in the material list. In these two cases, we again have the same scattering coefficient entered in the material list, but different distance from the source and different angle of incidence. This automatic scattering is added on top of the scattering due to roughness that you as a user enter manually. This is explained in more detail in our video on the reflection-based scattering method. By the way, these billiard ball animations are available in editions Industrial, Auditorium, and Combined, and they are explained in a different video. Another value we can set here is transparency. This is used to model moderate ratios of sound energy going through a surface to the other side. Specifically, it is the probability of a ray passing through the surface unaffected. Otherwise, the ray gets reflected with the corresponding absorption applied. For example, a transparency coefficient of 0.75 means that 75% of rays go through the surface, and the remaining 25% get reflected. Keep in mind that transparency can only be entered in the surface mode. You can repeat the transparency coefficient just as you can with the scattering coefficients. One application of the transparency coefficient is modeling a railing as a single flat surface, and then modeling the gaps by applying a transparency coefficient. Another application of transparency is to model curtains, where you can assign the absorption coefficients measured for the fabric, and then enter a transparency coefficient of around 0.5. Extremely low transparency coefficients, such as smaller than 0.05, should be avoided. The only exception is a transparency coefficient of exactly 0, which is the default for solid walls and works appropriately. If you need to model transmission of small ratios of airborne sound, like you would expect from a window or wall separating two rooms, then you should instead configure the surface as a transmission wall and enter reduction indices. Transmission should be used instead of transparency when the expected reduction is more than 10 decibels. Extremely high transparency coefficients higher than 0.95 should also be avoided. In this case, you should instead either just remove the surface or assign the transparent material from the material list, which will make the surface be ignored during calculations. When the transparent material is assigned to a surface, the outline of the surface will be shown with dotted lines. This lets you know that the surface is not physically present in the room. Another special material is material 1, which is 100% absorbent. This comes in handy, for example, to model open windows. The last property you can configure here is the wall type. To explain the normal and exterior types, I will briefly explain exterior and interior surfaces. Based on the distance from the room boundary, Odion will categorize surfaces as either exterior surfaces describing the room boundaries, or interior surfaces, which are mainly surfaces of objects inside the room. This is done in order to properly calculate diffraction scattering for each type. You can read more about this in Chapter 9.5 of the user manual. Surfaces with the normal type will be treated as automatically categorized by Odion, while selecting the exterior type will force Odion to treat them as exterior surfaces. As previously mentioned, Odion automatically applies edge diffraction. But curved surfaces should be modeled as a series of flat surfaces. In these cases, edge diffraction will result in excessive scattering. The fractional wall type is used to avoid this. Essentially, it treats a group of surfaces with this type as a single continuous surface, and so does not produce edge diffraction at the joints. You can repeat the last entered wall type with this icon. Here, the fractional setting gives a more realistic result. This is particularly important for concave surfaces. Convex surfaces like columns are expected to diffuse sound, so it's fine to leave those as normal surfaces. If you have adjacent coplanar surfaces with the same material, Odion will treat them as a single continuous surface by default, even with the normal wall type. But if adjacent surfaces are not coplanar or have a different material, there will be edge diffraction. Again, you can use the fractional setting to force Odion not to produce edge scattering at the joints. The final wall type is the transmission type, but that will be explained in our video on sound transmission. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!